So hello students, so I hope you have seen the video number 12 where I explain you about how to find SF and LCM by applying fundamental theorem of mathematics. Means I've given you the explanation, the algorithm involved. So let us find the SF and LCM by doing practically this question number 4.1, okay, from exercise 1C. So here I begin. So first of all, if you remember the explanation which I explained in video number 12, I told you that to find the SF and LCM of any two given positive integers, first of all you'd find the prime factorization of these given positive integers. So let's find the prime factorization. We have done this so many times. Here we write 306 and here we write 54. So let's do the prime factorization. As the word says, prime factorization means we are applying here fundamental theorem of arithmetic, and one of the fundamental theorem of arithmetic says that every composite number can be factorized as product of prime numbers. That means you have to do prime factorization here. You have to find the prime factors. So let's begin. 336 is the given number, first given number, so we'll now prime factorize it. So first of all, see, since we're doing prime factorization, then we should know all the prime numbers, as I told you, by heart all these prime numbers. So you can see that the first prime number is 2. That means first we should try with 2. And to be able to divide by 2, that is the first prime number, the number should be an even number. If you want to divide any given integer by 2, the number should be an even number. And remember, even number, how to identify? To identify even number, you have to look at the unit digit. Units times 100,000, no? The units place digit. If this digit happens to be 0, 2, 4, 6, 8, then that number is even number. And you can see that it's 6 here and it's here 4 here. Because these two given numbers are even numbers, okay? So we can divide by 2, okay? The first prime number. Let's start. Since 3 is bigger than 2, so we can take one time. 2 ones are 2. 2 2s are 4 big. So 2 ones are 2. So imagine that there's a 2 here, small 2. 3 minus 2, 1. That 1 goes and join with 3 from the left. So it becomes 1 and 3, 13. So you say table of 2 in your memory. So you recall. So find that since 13, so 2 6 are 12. So 12 is smaller than 13 because 2 7s are 14 big. So 2 6 are 12. Now 13 minus 12, 1. That carry 1 goes and join with 6. It becomes 16. 1 and 6, 16. So you know 2 8s are 16. Okay. So you can find that 8 has come. As you know, 8 is also an even number, so that's why 168 is even number. So even number we can divide by 2. 2 8s are 16. No carry, 6 minus 0. Now only 8. 2 4s are 8. 4 is also even, so we divide again by 2. 2 4s are 8 and 2 2s are 4. 2 is again even number, so we can divide by 2. 2 2s are 4, 2 1s are 2. So we got 21. But you all know that 1, when the unit digit of any number is 1 3 5 7 9, this odd number, so it's 1 here, this is an odd number. 21 is an odd number. Odd number we cannot divide by 2. So since we cannot divide by the prime number 2, now let's go to next prime number, that is 3. That means now we should try to divide this 21 not by 2 but by 3, okay, because we cannot divide by 2, so we'll try by 3. And yes, 21 is a multiple of 3. 21 comes in the table of 3, multiplication table of 3, so we'll divide by 3. 3 how many times? 3 7s are 21. 3 7s are 21. So we got 7. Okay, the moment you got 7, I told you try to by heart this prime number. So you can see that 7 is itself a prime number. 7 is a prime number, and for prime number no need to waste any time. So the moment come prime number, divide by 7 ones are 7, okay, because for prime number there's no other factor except 1 and itself. So by 1 we don't do, so by 7 we do, okay. So when you get 1, stop, okay. So prime factorization finished here, okay. Then let's do the same way for 54. 4 is even, so we'll do with 2. We take only 5 first. 2 1 is 2, 2 2 is 4, 2 3 is 6, 6 big, so 2 2s are 4. 5 minus 4, 1. 1 goes and join with 4, the 1 and 4, 14. 2 7s are 14. So now it has come to be 27. Now you can see that 27, because of this 7, now it is no more even, it is an odd number. You know, for odd number, what's the criteria of the unit digit? To become a number, for a number to become odd number, the units placed there should be 1, 3, 5, 7, 9. So this 7, so this odd. So odd number can divide by 2. So now we should try by 3. And yes, 27 comes in the table of 3. 27 is a multiple of 3. 3 nines are 27. So yes, you can divide by 3. 3 nines are 27. Since we have done by 3, so again we should do by 3. And moreover, yes, 9 is a multiple of 3. So 3 threes are 9. And the last 3, it's a prime number itself. So 3 we divide by itself. 3 ones are 3. So means we have got the prime factoration of 54 and we have got the prime factoration of 336. So since the question is clearly telling you apply fundamental theorem of mathematics, so that's why we'll just write the sentence here. By applying the fundamental theorem of arithmetic, we have, what do we have? This 336. You know, fundamental theorem of arithmetic says that every composite number, there's a composite number, can be expressed as a product of prime numbers. So this I can write as prime number. 2 into 2 into 2 into 2 into 3 into 7, which comes out to be, so see, 2 into 2 into 2 into 3 into 7. So now we'll express this product as the product of prime with the powers. Okay, so 2 we write one time because it's a prime number, but how many times it's coming? 4 times. So 2 raised to power 4. Okay, we write in the form of exponent. Okay, 3 is only one time, the 3 raised to power 1, and 7 is also only one time, so 7 raised to power 1. Okay, so we've got 336. Okay, clear? So now we'll do for 54. We'll write like this. 54 we'll write what? 2 into 3 into 3 into 3, which gives us 2. 2 is coming only one time, so 2 raised to power 1. 3 is a prime factor, but 3 how many times? 3 times, so 3 raised to power 3. So means we have finished the prime factoration of these two. Okay, yeah, of these two given numbers. Now we have to find what? We have to find the HCF and LCM. Okay, for these two numbers. So let's find the HCF and LCM. Therefore, HCF of these two given positive integers. Okay, therefore HCF of 336 comma 54. No need to write OF of what, because this bracket means off. Therefore HCF of 336 and 54 is equal to what? I've already told you that in my last video how to find HCF and how to find LCM. Okay, so let's see. Look, in this page number 9 from the book algorithm, I've explained you to find the HCF. They've clearly mentioned you that only mark the common prime factor and find the least exponent, and then raise the exponent to the lowest exponent and then multiply them so as to get HCF. Okay, in simple word, what I'm telling you is that here you first of all you see only the common prime factor, you mark them. Only the common what? That prime factor, that prime number factor should be present in both the numbers. If it's present in one number but it's not there in another, don't take. Okay, only common. So look, you can see that in this 336 the prime factors are 2, 3 and 7. See, these are in ascending order, small to big. In 54 also, these are the prime factor. These also in ascending order, small to big. Okay, so in these two prime factor, if you look very carefully, you can see that 2 is common. Look, in 336 also we have prime factor 2, and 54 also we have prime factor 2. So mark them. So 2 is common. But after marking them common, you write the smaller power of the two. This prime factor 2 has power 4 and this prime factor 2 has power 1 in these two numbers. So which is the smaller one? Which is the lowest exponent? Obviously, compared to 4 and 1, 1 is the lower exponent. So we'll write only 1. Okay. To find HCF, we take only common with the lower power. Okay, lowest power. Now it's the same here. In this 336 we have prime factor 3 also, and in this 54 also we have 3. That means the prime factor 3 is also common. So we mark. So we write multiply and write 3. See the second common prime factor. I repeat again, for HCF we write only common. 2 is common and 3 is common. See, 2 is present in both the prime factor and 3 is also present in both the prime factor. Okay, So 3 is also common. But see, in the first number, it's 336, 3 is coming, 3 is having power 1, and in the second prime factor 54, 3 is having power 3. After writing common prime factor, you write the power which is small of the two. Or if I have 3 4 numbers, then write the smallest power. So which is the smallest power here? If you look at the prime factor 3 and 3, here 3 is power 1 and 3 power 3. So obviously compared to 1 and 3, 3 is small, 1 is smaller. So we write 1. Okay. So write only the common prime factor, 2 common, 3 common, with the lowest power. In these two, 1 is the lowest power. In these two threes, 1 is the lowest power. Okay. Now what about 7? See, in 336 in prime factorization, 7 came. The 7 is a prime factor of 336. But 7 is not a prime factor of 54. That means what? 7 is not common. Since 7 is not common, we will not write. I repeat again, any prime factor which is not common, we will not write while finding HCF. Okay. So in HCF, we write only common with the lowest power. Okay. So now let's multiply. 2 raised to power 1 means what? It means it's 2 1 time, means it's power 1. Power 1 no need to show. 3 raised to power means what? 3 is 1 time. 3 is power 1. 1 time. Power 1 means 3 is 1 time. So now multiply 2 into 3, 6. That means the HCF of these two given positive integers is 6. Okay. Clear? Now let us find LCM. LCM of 336 and 54. As explained in the last video, this one. For LCM, list all the prime factor. For HCF, only common, same, common. But for LCM, all prime factor, common, uncommon, doesn't matter. Okay, only it should be present. Write all the prime numbers which are factors, okay, which are present in prime factorization. Any prime number which comes as prime factor, write all. So write all the prime factor which occur in prime factor, and then raise each prime factor to the greatest power. And while finding LCM, there's a difference between HCF and LCM. In LCM, we write the lowest power of the two or of all, but in LCM, we write the highest power. Means write all the prime factor with the highest power and then multiply them to get LCM. That means now you can see the prime factor in 336 and 54. So write all the prime factor, means write all the prime number. 2 is a prime factor, so write 2. 3 is a prime factor, so 3. Only once, don't write the 2 is 2 is here, 2 is here, write 2 times. No. 2 is a prime factor, 2 is here also, so no need to write. Okay, write only once. Clear? 3 is a prime factor, 3 is present here also, but doesn't matter. I said common, just should present. 3 is present, 3 is present. So but just write only once, because though 3 is here also, but write only once. And see, if you look very carefully, 7 is also a prime factor. Is there any other prime number? See, 2, 3 and 7, 2, 3 and 7. 7 is here, not here, but it doesn't matter for LCM. For LCM, we write all the prime factor. So in total, if you look very carefully, only 3 prime numbers we have. There's 2, 3 and 7. Now, after writing all the prime factor, you write this prime factor with the highest power. So now come back here. In this prime factorization, you can see that 2 is a prime factor, but see which is the highest power here. Here 2 has power 4 and here 2 has power 1. So among these two, the highest power is 4, so we'll write here 4. For LCM, we write highest power. Same here. See, for 3 prime factor, for the prime factor 3, here power 1 and here power 3. The 3 is bigger, or 3 is the greatest power, so write the greatest power. Okay, Q. Means for LCM, we write prime factor with the highest power. For LCM, we write only common factor, only common prime number, prime factor with the smallest power. For LCM, we write highest power. Okay, clear? And see, 7 is coming one time, and see power 1. There's the highest factor, because there's no 7, so there's only 1, so there's only highest. Okay, for itself. Okay, for this particular question. So that means here we have a product of all the prime factor with the highest power. Say with the highest power. Okay, now multiply them. Now 2 raised to power 4, I think you all know. 2 raised to power 4 means what? 2 how many times multiply? 2 raised to power 4 means 2 how many times multiply? 4 times. 2 raised to power 4 means 2 into 2 into 4 times. So 2 into 4, 4 into 8, and into 16. So it comes 16. Clearly remember, it's not 2 4s are 8. It's not 2 into 4. It means that 2, 2, 2 to 4 times. So it coming 16. Same here. 3 cube doesn't mean 3 into 3, 9. It means 3 into 3 into 3, 3 times. 3 raised to power 3 means just 3 multiply 3 times. Just 3 multiply 3 times. 3 into 3, 9, 9 into 3, 27. 9 into 3, 27. So this gives us 27. and 7 raised to power 1 is what? 7 is only one time. So, okay, so 7 means power 1 only to show. Okay, I showed for explaining you and to complete the process, but then power 1 means the number itself. Okay, only one time. Now let's multiply all this 16 into 27 into 7, so you'll get the answer. So let's multiply them now, all these numbers. So let's multiply now. First multiply 27 and 16. 6 42, 6 to 12, 13, 14, 15, 16, 177, 1, 2, 2. So it's giving us 432, and then we'll multiply by 7. After you multiply 16 27, then again multiply 7. So 7 2s are 14, 7 21 22, 28 29 30. So it's coming 3024. 3024. So it means that the LCM of these two given percentages is 3024, and the HCF of these two percentages is 6. So let me quickly just tell you what we have done. The question asks us to find HCF of these two given numbers by applying fundamental theorem of arithmetic. So what we have done is that first we have done the prime factorization of these two given numbers. Okay, clear? Then after doing prime factorization, then we write here by applying fundamental theorem of arithmetic, as the question is telling us applying fundamental. So we have found the prime factorization. 336 is the product of all these numbers, and we write in power form. They're also in ascending order, smaller to bigger. And for 54 also we write product in this way, and then we write in power notation. Okay, power form, exponential form. Okay, with ascending order. Okay, in ascending order. Then after that, to find HCF, let me tell you once again, to find HCF of these two given percentages, we write only the common prime factor. That's why we have marked 2 2 is common and 3 3 is common. 7 not marked because 7 is not common, so we write only 2 and 3 first common. That also with smaller power. 4 and 1, 1 is smaller. 3 and 1, 1 and 3, 1 is smaller. So write 1. Then 2 is power is 2 only, 3 is to power is 3, 3 only, and multiply this to 6. That means the HCF is 6. Okay, highest common factor of these two numbers is 6. And how we found LCM? Same thing we did. After to find LCM, what to do? We first write all the prime factor. 2 is present, 3 is present, 7 is present. See, there's no other prime number. 2 3 7, so write all, but with the highest power. 4 power, 3 is the highest power. For 2, 4 is the highest power. For 3, prime factor 3 is the highest power. And for 7, 1 is the highest power. Write all with highest power. Then we multiply to get the answer. So students, I hope you have understood this question number 4.1. So I want you should try question number 4 sub number 2 by yourself. Okay, clear? Thank you so much.